Hi, in this video, I will implement a gesture recognition system based on the paper Machine Learning Based Gesture Recognition Graph Design and Implementation, published in Sensors 2024. The paper presents a smart graph system that combines flex sensor, force sensor, and IMU data to recognize 5 game control gestures. I will show you how to implement their deep learning approach using Google Colab. Let's first understand the dataset structure. As in the paper, they provided in supplementary material. Each record contains 5 flex sensors, 1 per finger, 5 pressure sensors, IMU sensor data, including orientation and acceleration, 121 time steps at 100 Hz, giving 1.21 second per gesture. The gesture include fist, double tap, finger spread, wave left, and wave right. The datasheet comes with 100 samples, each having 142 features representing various sensor reading. All details described in the README file from the paper, explaining how to use this data and how do we analyze it. So let's start with Google Colab. Let's open new book. So let's name this one CS 6000. Let's name it Graph Data Machine Learning. Let's start with downloading the dataset. So I will copy this URL. I will store it in local directory. So the file is it's a zip file. It's downloaded in Google Drive here. Let's see the content of this zip file. So it's contain the comma separated file as described in the README file. So the other file we don't need to extract it, so I will ignore those. Here we have the comma separated file in local directory. We can see the header of the file using this command. Head of game. As we can see here, the data as represented in the README file. Here, this is the header containing this information. Now the data is stored in the Google Drive, so we can start analyze this data. Let's set up our Colab environment. So we will start importing required libraries. Execute it. So it's right now installing the TensorFlow or related library. So all done. Now let's examine our data loading and pre-processing functions. So this function is to be processes the sensor data from the comma separated file. Now let's do the feature extraction. So we need to define this function, also add this one as well. Following the paper architecture, we will create a CNN with 3 2D configuration layers. So this is the model creation function to create neural network model or CNN according to paper architecture. Let's implement the training function. Here the training function and training and evaluate function. This require the data path and will return the model and history and scalar. Let's execute this one. Result visualization. So after we train the model and evaluate it, so we can show upload for our training. Finally, let's save our model and results. Right now we have all base function that we need. We will use it to train our model, extracts the features, creating models, and results visualization. Lastly, the saving and results. Let's do the training. Data path is game. So data path is equal to game, the file, we have it here. Also we need later to use the result to be stored in the result folder. Let's start the training. So the training finish, and we have here the classification report. Store result. Store it there. So the result now has the output here, the trained model, and the training history as well. Let's see the visualization using our method we just implemented a few moments ago here. That's using the output from the training history. So okay, and now we can see our result according to the trained model. Now we can download our data. Download. Okay. Now here we have the downloaded data. That one is 15 megabytes, and the history as well. The saved model can be used for the real-time gesture recognition task. Thank you for watching.